Uh, so today we are going to discuss another very important topic in data mining. This problem is based on cluster analysis, as you might have guessed by the topic written here. So let's solve. Use the similarity matrix shown in the table below to perform single, complete and group average hierarchical clustering. Show your results by drawing a dendrogram. The dendrogram should clearly show the order in which the points are merged. So we are given this similarity matrix. The thing which is to be noticed carefully here is we are given a similarity matrix and we are asked to basically perform these three: single, complete link and group average hierarchical clustering, right? Three. So and then draw the dendrogram in finally. But if we carefully analyze the distance metric that is required to basically make the cluster depends on dissimilarity, because similarity is the nearness. So if we have been given the similarity matrix, we must convert it into dissimilarity matrix so that we can get the distances. So as it is written here, that we are given similarity matrix, but we would require dissimilarity matrix that would define the distance between the data objects, right? So, and for that we have this formula: dissimilarity is equal to 1 minus similarity, and using this we can just basically recalculate the values in this table as I have done it below, right? So just nothing, just subtract what is given in the similarity matrix, that is 1 minus that, so we will get these values. So all these values are now converted into dissimilarity matrix, and 0, which is like here or in all these places, is nothing but like obviously, because both the points, distance between the points will be 0 only if a point like point P1 is at distance 0 from itself, right? So that is what is written there. What we must be doing here to like solve the problem in a more efficient manner is just mark the distances in ascending order. Like 0.02 is the minimum in the entire table, so it is 1, then 0.15, then 0.24 and then 0.36, right? So all these four. Now using single link. Now single link means we will consider the minimum distances of a point from the cluster. This is the meaning. So single link. So now we see that 2 and 5 are the closest, so we group them together. In the entire matrix we see that 2 and 5 are the closest, so we group them together as shown in the right side. Right side you will see the cluster at any particular stage of the calculation, right? So 2 and 5 are clustered together. So now for the next step, since this was 1 and then 2 comes for 3 and 5, so it is 2, so then we take 3 and 5, right? So distance 3 and 5 is equal to distance of 3, and you see here we have the set, because now 5 is a part of the cluster, so 3 comma 2 comma 5. And more important point is this is also equal to distance 3 comma 2, because again we will be referring the same cluster, that is 3 comma 5 and 3 comma 2, the cluster 2 comma 5, right? So this will be equal to minimum of, why minimum? Because single link considers minimum distance from the cluster. So minimum distance of 3 comma 2 comma distance of 3 comma 5. So distance of 3 comma 2 will just refer from the table. So for 3 comma 2 we have 0.36, so 0.36 is written here, and 3 comma 5 consequently is 0.15, so we have 0.15 here. Now the minimum of these two is 0.15. Now we similarly calculate distance of 3 comma 1 and then 3 comma 4, because we need to take the minimum out of the entire like what are the distances possible. the distances possible would be 4 to this cluster, 1 to this cluster, 3 to this cluster, a distance between 1 and 3, distance between 1 and 4, distance between 3 and 4, all these, right? So we need to consider the minimum. So if we see that distance of 3 comma 1 is 0.59, distance of 3 comma 4 is 0.56, and distance of 3 comma 5 is 0.15. Moreover, if we consider the table, the next near most least distance is 0.24, which is between 4 and 5, right? And it is less than that, that is the minimum is less than that. So we need not worry to check any other distance, and we can simply take it as the minimum. So then the cluster will look like this. Earlier 2 and 5 were in a cluster, now 3 along with this cluster forms another cluster, and it is shown like this. Now in the next step we consider 4 comma 5. Why 4 comma 5? Because 4 comma 5 comes in third, right? So then we take distance 4 comma 5, which is distance of 4 comma 2 comma 5 comma 3, because now this 3 acts as a cluster. So it will be minimum of distance 4 comma 2, distance 4 comma 5, distance 4 comma 3, right? Again we'll use the matrix to get these values, and 0.24 is the minimum. So we can see that again another cluster is formed outside the previous cluster, right? And one is left behind, it is not yet clustered, right? And we can see that in this step the minimum distance is 0.24. You can also check the other distances, but the process I mentioned earlier, like the 1, 2, 3, 4 values which we have given in the matrix, we need to just infer them, and if the value calculated comes to be less, then we need not worry further, and we can straight away form the cluster. Now once 4 is also clustered in, only 1 is left, right? So we need not compare any more distances, we can just club this one into the cluster. So again we will do the same thing, min of distance 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, which is 4.45. So now the final thing, the dendrogram, sorry for the spelling mistake. So the dendrogram is drawn such as this. On the y-axis we have the similarity. Note it is similarity, not dissimilarity. And in the x-axis we have the data points. So first 2 and 5 are clustered together at a dissimilarity distance of 0.02, which converts to 0.98 in similarity. Similarly, 0.3 is clustered then at 0.15, so it will be 0.85, because in similarity it will be 0.85, and then with 4 at 0.76, and then with 0.1 at 0.55. So this way we will form the dendrogram in single link. Now let's come to the complete link, which is also called max or click, right? So in this what we will do is we will consider the maximum distance of a point from the cluster. We see again that 2 comma 5 are the closest to each other, so we group them together. Because there is no cluster here, so there is no question of calculating max or min, right? So 2 comma 5 is clustered together. For next step, again we will follow that ordering 1, 2 and 3. So we take 3 comma 5, and this time see here I have highlighted max of distance 3 comma 5 comma distance 3 comma 2. So then we have 0.15 and 0.36 from that same dissimilarity matrix table, and then we will say that 0.36 is the distance. Why? Because we are taking the maximum. Similarly, we will calculate for the next, that is number 2, that is 4 comma 5. So in a similar manner it comes out to be 0.53. Again distances we take, right? We can also check all the conditions, but it may take much time, so I have reduced it and used that scheme which I told you earlier. So distance 1 comma 4 is 0.45 and distance of 3 comma 4 is 0.56. In all the combination 3 comma 5 was the smallest. Why? Because its value is 0.36. So then we will have this cluster, right? In the next step, we take 4 comma 5. Why? Because 4 comma 5 comes next in ordering. So then we have 4 comma 2 comma 3 comma 5. Again we take max of 4 comma 2, distance 4 comma 3, distance 4 comma 5. We put in the values and we see 0.56 is the maximum. Then we see 1 comma 4, so it comes out to be 0.45. And then we see 1 comma 5, so it comes out to be 0.9, right? So in all these three we see that 1 comma 4, this time 1 comma 4 is the smallest with a value of 0.45. So we have this like 1 comma 4 as the smallest. Now we cluster these two together, 1 and 4, right, because it is the smallest. Once that is done, so we will proceed with the last step, that is only two clusters are remaining, so we will club them. So we can do anything like 1 comma 5 or 4 comma 2, anything, but the same distance will occur as we have as I told you previously. So maximum of all these we need to calculate, right? We see that 0.9 is the maximum in the table, so we need not calculate the other values. We simply put 0.9 and hence finally all the data points are clustered. So now we see the dendrogram. Again we map the y for the similarity and x for the data points. 2 and 5 were the nearest, so we first basically clubbed them, then 3 at 0.64, then we clubbed 1 comma 4, right? See, it is different from the previous, that is single link. So at 0.55 distance, sorry, at 0.55 similarity, and then at 0.1 similarity we clubbed these two. Okay, so that was max or click or complete link. Now we come to the last part, that is group average. So in group average what we do is we take the average of the distances and basically that is considered to be the distance of the point from the cluster. But since we are starting off, so all the points are data points itself, so 2 and 5 are the closest, so we group them together again. Next we take 4 comma 5. We can take 3 comma 5 as well, which I will take in the next. I just by mistake I took 4 comma 5. So distance 4 comma 5 is 4 comma 2 comma 5 because these are clustered previously. So it will be distance of 4 comma 2, that is this element and this element, plus distance of 4 and 5, these two elements, divided by 1 comma 1 into 2, where this 1 comes from number of elements in item in this set, that is in 4, and 2 comes from number of items in 2 comma 5. So a number of items here is 2, so 1 into 2. So then we get 0.53 plus 0.15 divided by 2, which is 0.34. So then we have distance of 1 comma 4, which is 0.45. Then we have distance of 3 comma 5. So in a similar manner, because these are not clustered, so we need not put any group average value. We can directly state that from the dissimilarity matrix table. Again we took 3 comma 2 plus 3 comma 5 and 1 into 2, because 2 elements here and 1 element here. So we calculate that and the value is this. The smallest distance we can get is 0.255. You can check this since the next smallest distance from the dissimilarity matrix is 0.36, which is higher. So we need not check further. So then we have this particular cluster ordering. Next we check 4 comma 5 according to the ordering. So it is 0.53, 0.56, 0.15, 1 into 3. So we get 0.4133. We can check further also. So 1 comma 5 comes to 0.7133. So comparing all the distances, we get that the smallest is 0.4133, hence 4 will be clustered. So 4 is now clustered. Now last two must be clubbed, as I mentioned earlier. So we perform the same operation, since one is not clustered but rest all are clustered. and here you see 4 comes from the cluster count 1 2 3 4, like 4 items are clustered here, so 4 and 1, since 1 is separate, so we can calculate that, and hence the dendrogram will be like this, right? First we did 2 comma 5, then 3 was clubbed in, then 4, and then finally 1 at a distance of 0.35. So this is how we will proceed with like creating dendrograms. I hope you all understood what I tried to explain. Thank you.